All right, it is your boy, the Caneologist. It's me, and we're going to be doing a very important question today. Implementing a queue using stacks. So in one of the previous questions, we implemented a stack using queues. Now we're going to implement a queue using a stack. And like you guys saw before, ChatGPT isn't always right. Don't fully depend on ChatGPT. You still have to use this. This is the real treasure, right? ChatGPT can't eat ice cream. You can, right? And you can experience the sensations and the goodness because you're human. And that's what this is about. This is about being human, learning, solving, and getting better, right? We're not machines. We are human. So let's get to this question. Implement queue using stacks. Implement a first in, first out. This is called FIFO, first in, first out. Let's open up the whiteboard, my favorite tool, because I can illustrate my thought process on this panel, which is what I'm going to do right here. Let's take this, let's take that, and I want to check the thickness of this marker. Okay, so this is how a queue works. Pretend this, actually wait. Let's cancel out this. Let's erase this. Oh my gosh. Let's erase these dots. Okay. So pretend there's contents in this list. Okay. So first in, first out is basically first in. So the first element in, first element out. The way a stack works is a LIFO. So the stuff right here. So it means the last element in is the first element out. This is LIFO. They call this LIFO. And they call a queue FIFO. First element in, first element out. Okay? So that's just a quick rundown of what these terms mean. So the implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. I had some chicken katsu before I did this, so like, excuse me if I'm like pausing. So I'm actually still full. I'm actually still full from that food. It was actually delicious, I'm not gonna lie. Back to this question. Implement my queue class. Okay, so all we have to do is, we don't have to do anything crazy, right? We use the existing functionalities of a queue for this queue-based stack, right? So void push int pushes element to the back of the queue. Okay, so if I just do this, self.push element X. Push peak thing. Okay, so dot push. Pop. Right, so this is self dot pop. Just gets rid of the last element. What pop does, it just takes off the last element. It's like popping the cap off a water bottle. The water bottle's on the very end, and you pop it off. Boom. It's the last element on that water bottle. The contents inside are underneath the cap, so it stays inside. Only the cap comes off. Right? Peak. What is peak? Returns the element at the front of the queue. So, oh yeah, with all these we gotta have a return statement. Returns, that way our function gives us some sort of a result. Return self dot what am I doing? Return self dot element 0. I don't know. How do you peek itself? Unless it has a built-in peek function. Boolean empty returns true if the queue is empty, otherwise false. So if run oh, and this is just an array. So what did I do for this? I have to go self.stack equals empty array. So now it's just an empty array. So now I go stack self.stack. So it's gonna be self, which is gonna be this array dot push pop, return the first element. So that way I could just do this. Let me try that. Is this the right syntax? I don't know if this is the right syntax. Maximum recursion depth. Why? Why do we recurse thing? Define properties of a Python object. Self.name equals name. So self.thing equals thing. Self.name equals name. Self.stack equals this. So self. My queue object. Return stack. It doesn't matter what I name this, because self is itself, and stack, self.stack. For example, if I was to look at a previous question with an object, I just want to see, so it's self.val equals val, all right? So that way I could just define it as val. Self.val, and then you replace that with root, so stack.val. This would be self root.val root.left. Let's see. I'm looking using stacks. Implement queue using stacks. Push pop peek. Yeah. Implement queue using stacks. Okay, so I have my stack here. Self.push. Self.push, self.pop. equals 0. This is the portion where I'm kind of stuck. What time am I at? 10 minutes? There's another syntactical sugar method that I'm just like not getting. Recursion. Why are we using recursion on this? Self.push. Oh, because it's calling itself. Okay, so that's why. Let's do this. Self.appendx. Runtime error, no attribute append. Why? This is literally a array. Let me try this. Self.stack append. Does that work? Okay, so this is where we go. Self.stack. And this is the thing about nodes as well. I want to return self. Self contains a stack. Self.stack.append. Self.stack.pop. Self.stack at element 0. If len self.stack equals 0, return true else false. This should work if this is how it's supposed to be. Case 1, push pop peak empty, output null 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 1 2. Okay, so what am I doing? Where is it fucking up? Push pop peak. So it's null null null, output null 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 1 2. Okay, why 1 1. Push X, okay. Object push X, okay. Object.pop, self.stack.pop. Because it's non-inclusive, so I could just go len stack. Oh, I can't refer to itself. Oh, I could go stack. It's genius. Pop. Why? Okay, so it doesn't allow you to. if I do this? I'm curious. I'm just curious. I want to explore curiosity. Let's see if I can manipulate this. And then return self.stack without the last element. Does that work? No. Okay. I'm just curious. Python Playground, my other best friend other than the whiteboard. Right, so if I go Python Playground, one, two, four, I got this. LSD.pop. I'm just curious if it's built in. Print LST. Does that show me 1, 2? Okay, yeah, it does. So if I just go pop on an array, on a list, self.stack.pop, that should pop for self. But this would also cause a recursion. That's what I'm thinking. Which is why I would just want to go I want to do this, but it won't let me. But the same way, I can't go self.stack.pop. Push also does the same thing where it kind of self.stack.pop, self.stack.pop, self.stack.0, returns self.stack.0, false, false. It's like, okay, everything is good except for one thing. What am I not doing right? Where does it fail? Peak empty. So null, null, null. My queue. Null. Push 1. Push 2. Peak. Pop 2. Empty, false. Okay, I want to know what's wrong with this. My queue. Okay, it'll be 1, 1, 2. So push again, peak, return 1, pop, return 1, Q is 2. What does it say for pop here? Removes the element at the front of the queue and returns it. Oh, okay. Pop returns the element at the front of the queue. Oh. Okay, okay. Self.stack 0 is the element at the front of the queue, and then self.stack 1 to the end. Return. That should fix why. Why? Oh, okay, it returns it. Okay, so self.stack, it's not expecting that as the return value, that's why. So then I go 1 to the end, so it skips the first element. Then I return item. That should be the answer. That should fix the yes. I'm a fucking beast. Okay, let's see it. Come on. What? Why is this happening? Okay, so now it's checking empty. If length of self.stack is 0, return true. You know why? You want to know why? Self.stack, this. Boom, submit. This should work now. There we go. I'm a beast. I'm the smartest guy on the fucking planet. It all comes down to understanding the syntax. This is why I say, guys, it's not fruitless to do the easy questions, because by the time we get to the mediums, the hards, and all that, sure, you can use fucking Kurosawa's algorithm or like Booth algorithm or like what's that guy's name? You can use fuzzy logic and all this fucking weird shit, right? All it comes down to is the basics, right? Do you know lists? Do you know arrays? Do you know how to manipulate objects, right? Do you know how to define your objects and then go back to them, right? So I noticed here, everything's working. It's checking the right lengths, but my output's not correct. Why? Right? When I fix the pop, I'm returning the item. So right then and there, it told me that pop was wrong originally before I made this final change, because it was expecting a value and not an array in return. So now I returned a value and it passed all the tests. When I submitted it, it failed. Why did it fail? Because it returned a value, but the result of that returned value didn't alter the original array, the original object, right? So I was given the right value back for the pop, but the array remained the same after that function. And that is where the mistake was. That's why I went and corrected this by saying the array is now, after I get this last item from the front of the queue, after I take this out, fuck, I just hurt my elbow. Fuck. Bear with me. Okay. I just hit my elbow on the desk, on the sharp part. You guys know what I'm talking about. So after I remove this item from the front of the queue, right, I need to now return the new array with that removal. So I go self.stack is now this new slice of self.stack minus that first element that I took out. And then I return the item. That way it passes the test. And then when I go to submit it, it will pass the other tests in this challenge. And as you can see, this beats 91.44% of solutions. And all I had to do was leverage existing list qualities. You know what I'm saying? The list already has built-in functions, right? The reason I couldn't use pop earlier on this is because it's just going to call itself, and it's going to call itself, and it's going to call itself. It's going to be recursive, right? So that's the same thing I did with push, right? If I do push, it's going to call itself. Right? So then I just use slices, get around that, and then I use append, the built-in function of a list, get around that. And there you have it. A fully packaged solution to this problem, and it beats everyone, pretty much virtually 91% of people. All right, so if you like that video, give it a thumbs up, subscribe to the channel, and leave your comments below. Knologist out.